Hello everyone, in this video I'm going to go through the AQA Combined Science Physics Paper 1 Higher Tier from 2023. This Paper 1 Higher Tier is tested on 4 main topics, which is electricity. So the first topic is energy. Just bear with me. We've got energy, electricity, particle model of matter, and the atomic structure. Question number 1 is on the topic of energy. Wind power and solar power are both renewable energy resources used to generate electricity for the national grid. Which of the following is also a renewable energy resource? That would be geothermal. Purple color. Give me 1 second. The pen doesn't seem to work. There you go. So, question 1.2. The energy transferred by the national grid in 1 second is 36 gigajoules. Which of the following is the same as 36 gigajoules? 36 gigajoules is 36 times 10 to the power 9 joules. Remember, if you want to remember, this 10 to the power 3 means kilo, 10 to the power 6 means mega, and 10 to the power 9 is giga, 10 to the power 12 is tetra, and I've got a small table to help you remember this. Terabytes or tera, right? So metric values, this will be useful to remember. Figure 1 shows how the mean power output from solar and wind energy resources in the UK varied between 2014 and 2019. So let's interpret these graphs. You've got a bar chart followed by a line graph. So let's have a look at the bar chart first of all. As you can see, between 2014 to 2019, there's a general increase in the amount of wind. I was hoping to be a straight line. Let me try that again. So there you go. So the general trend is actually it's increasing, except for 2016, where it seemed to have dipped. And now there's 2 reasons. Why is there a general increase in the trend for wind power? It's not because it's got more and more windy, right? It's probably got less windy in 2016. That's why it could have been a drop. The general reason why it's actually increasing is because more wind turbines were probably being built, hence more electricity were being generated. Now the solar tend to have increased up to 2017. The increase in the solar is actually far less than in the wind power. Again, I'm trying to get a straight line for this. There you go, right? And then it seemed to have been stable. So again, the reason for the increase could be that they were building more solar, putting up more solar panels, right? Not because it got more sunlight in the UK, right? Remember, we are talking about the UK, so we rely more on the wind energy because we are an island, we are surrounded by coast, and being in the northern hemisphere, it is generally more windy than it being more sunny. So let's have a look at figure 2. Shows how the power output from solar and wind energy resources varies in a typical year. So at the start of the year, right? So January, February, we are more or less during the winter months, as we are probably in the December as well, winter months, right? Now May, June, July, right? I would say June, July, August, right? That's the summer months, or to the start, that's the spring, right? And this is the autumn months. Right? So when we look at the amount of wind energy during the winter, it's actually high, right? Start of November, we could say it's also high, right? And then during the summer months, the amount of wind energy generated is actually the lowest is in July, which is right in the middle of the year, which is during the summer month. But if you look at the amount of solar power is at a maximum between May and July. So during the summer months or towards the end of the spring. So what is the question actually asking us? Explain the changes in power output from solar and wind energy resources between 2014 and 2019. You should include an explanation of the change in power output during a typical year as well. So the second part is actually to do with the, right? So the second graph, because that graph is actually showing that in a typical year. The first one is mainly to do with the bar chart, right? Explain the changes in output from solar and wind energy resources between 20 and 4. So between those 2 years, between 2014 to 2019, both has actually increased. You could say, you could give quote values. So this is 3,600 in 2024 megawatts, and it went up to 7,300 megawatts for the wind power. So it increased by 5, 6, 7, 8, 7,000, no, 3,000. So let me do that properly. So 7,300 minus 3,600 will give me 3,600. So wind power increased by 3,700 megawatts. Solar, it went from 400 to a maximum of 1,400. So solar only increased by 1,000 megawatts. Again, you can quote values from here. The lowest for the wind, right? So lowest is in the summer and the highest is in the winter. The lowest is 1,800 megawatts. The highest is 6,700 megawatts. Solar, the lowest is 400 megawatts and the highest is 2400. So 2400 megawatts. So let's have a look at the marking scheme answer. And the marking scheme is actually splitting the answer into two sections. So if we look at figure 1, the power output from wind increased. And again, because the question is asking you to explain the changes, you need to give a plausible reason for it. The power output from wind increased because more wind turbines were built. The power output from solar increased because more solar panels were increased. So you can write that as one sentence, right? Power output from wind and solar may have increased due to climate change as well, right? From 2015 and 2016, wind power was lower in 2016 than in 2015 because 2016 was less windy than 2015. Of course, you can actually write more reasons for it. Figure 2, for most of the year, the electricity generated from wind is greater than from solar. The electricity generated from wind is greater in the winter than in summer because winter is windier than the summer months. The electricity generated from solar is greater in the summer than in winter because number of hours of sunlight are larger in the summer and the intensity of sunlight is greater in the summer as well. Again, I explained, given more information here in the graph, and it doesn't actually hurt when you are doing the answering the questions to interpret some of the information on the graph. So if you run out of space, examiners can have a look at what your answer is and the notes as well, and maybe you can get all 6 marks, or you should be getting 6 marks. So remember, to access level 3, the answer should describe the trends in both graphs and in solar power and wind power and give some explanations for changes. That brings us to the end of the first question. Let's have a look at the second question.